Welcome to this video on free body diagram application from Actus Potentia. In this video, I will show you how this software helps us in analyzing complex frames and machines. If you are not familiar with how the software works, I would recommend that you should watch this video for instructions, and you can download the software uh, at this website. So what is a free body diagram? The free body diagram is a sketch of a body or a part of a body that is isolated from its surroundings. So in this picture we have an earth mover, and we would like to analyze the front portion of the earth mover. So first we start with a sketch that shows the effect of the surroundings, and the surroundings include the load on the earth mover coming from the dirt at this point, and all the pins and connections and the hydraulic cylinders and so on. We will analyze only a part of this body, as I said before. So what we do is, the whole machine is here. We take this pin off and this pin off and separate the front part of the body. But we will have to include the effect of these two pins. So there will be two forces here and only one force here. One force here because the hydraulic cylinder is a two-force member. We will use Actus Potentia's FBD software to draw the free body diagrams. So here is a skeletal diagram of the front portion. Here is the pin at A that we removed, and here is the other pin, and we have a hydraulic cylinder here, another hydraulic cylinder here, and another hydraulic cylinder here. This is the bucket at the front, and this green arrow shows the force or the weight of the dirt that this earth mover is lifting. Actus Potentia's FBD software draws free body diagrams and also shows you the solution strategy. The solution strategy is shown in a table like this, and in the first step the software is telling us that we should analyze the bucket. Why did it choose the bucket? Because the forces on the bucket can be easily determined. We have a pin here at D and two forces coming at the node D, and at pin K, which is attached to a two-force member, we have a single force coming at node K. And as before, this green arrow shows the weight of the dirt. So in this free body diagram, what we have is we can write three equations, two force balance equations and one moment equations, and we have three unknown forces, 1, 2, 3. So by applying the force balance and the moment balance equations, we can determine these three forces. After those three forces are determined, we go to pin K, and we already know this force from the previous free body diagram. So from the equilibrium of the pin, we can calculate this force, because this force is equal to that force, and then transfer this force to the two force member IK, and now we know this force, and from the equilibrium of this two force member we can calculate this force. Then we go to pin I. In pin I, we know the vertical force that is coming from the member IK, but we do not know the forces coming from this member and also the hydraulic cylinder. So at pin I, we have two unknowns, one from the two-force member IL and one from the hydraulic cylinder IJ. For the pin, we can write only two equations, force balance equations, and by solving those two force balance equations, we can calculate this unknown force and that unknown force. Once we calculate this unknown force, we know this force and that force. Those are the forces on the hydraulic cylinder IJ. So those are now determined, and also on the two-force member IL, we know this force and we can calculate this force. Then we go to this complex member, which is this vertical member coming from ECJLD. So this is the free body diagram of that member, ECJLD. Remember, at node J, we have the hydraulic cylinder. We already calculated the force on the hydraulic cylinder. Here we have a two-force member, which we have calculated this force. And at node D, we have calculated this force. From here. So we see that on this vertical member, which has lots of pins and lots of forces, the forces at node D is known, force coming from the two-force member Li is known, force coming from the hydraulic cylinder Ji is known. So this free body diagram contains three unknown forces. One is at pin C and one is at pin E. At pin E, we do not have two forces because pin E is connected to a hydraulic cylinder, which is a two-force member. So the force at E is a single force along the hydraulic cylinder. So we can calculate 1, 2, 3 forces by writing three equations, which are the moment balance equation and two force balance equations. Okay, let's move on. So now we know the force at E, and so we can calculate the force at F, and that will be the force on the hydraulic cylinder. Then we go to the member AHFC. So we have already calculated this force at node C. We know the force from the hydraulic cylinder FE, and just because FE is a two-force member, there is only one force here. So in this free body diagram, we have three unknowns. The two forces coming from the pin at A, and at node H, we have another hydraulic cylinder connected, but the hydraulic cylinder is a two-force member, so the force at node H is along the hydraulic cylinder. So in this diagram, I have only three unknowns, 1, 2, 3, and we can write three equations, so we can calculate the forces, two forces at node A and one force at node H. So we follow the strategy given here and go from free body diagram to free body diagram and solve the whole problem. this concludes this video. Thank you for watching.